Hey everyone, my name is Miles and I'm one of the SIs for Chem 1B, and today we're going to go over the applications of entropy, and generally entropy. So first thing I'd like to just discuss, what is entropy? So entropy S. So there's two important definitions for entropy just to review before we get started. The first definition is the measure of disorder or randomness. Okay? And the second definition is the number of microstates. So if you have a lot of, I'm going to put MS, microstates, that means you have a high entropy. Okay? So these are the two definitions to keep in mind when you think about entropy, microstates, and disorder and randomness. And to jump into more of the applications, one important aspect is that delta S entropy is always going to be proportional to temperature. So for example, if you increase the temperature or have a high temperature, that's going to equate to a high S, because the particles can now spread over a greater area and can move at a faster speed because they have a higher kinetic energy. The second proportionality is delta S is always going to be proportional to volume. So this means if you increase the volume, that's going to lead to an increase in delta S. So if you make a space bigger, so if let's say you have a container that's 1 liter and you increase it to maybe 2 liters, you're going to have an increase in entropy, because now there's more areas in space where your particles can be. And the last one is delta S is always proportional to the number of particles. And an example of this is, let's say you have A goes to B plus C. Okay? So you can see there's 1 mole of A, 1 mole of B, and 1 mole of C. And from this reaction, we go from 1 mole on the left on the reactants to 2 moles on the right. So you can see that we increase the number of particles from 1 to 2. Therefore, this has to have an increase in entropy. And these are the three proportionalities to keep in mind when you're thinking about entropy: increased temperature, increased volume, and then number of particles. And then you can also think of an increase of volume. That's the same thing. An increase in volume is the same thing to a decrease in pressure. So they're the same concepts. Okay. So now moving on, another topic to discuss is what is spontaneity and how does it relate to entropy. So this is a bit interesting, I think. So the key idea that the second law tells us, second law of thermodynamics, this is what it tells us. It tells us that a spontaneous reaction is always going to have a delta S universe that's greater than 0. So the delta S of the universe, if that's ever greater than 0, so like 1, 2, 3, etc., any number greater than 0, you're going to have a spontaneous reaction. And it doesn't necessarily matter what the system and surroundings are, if they're like a certain number. If the delta S universe is greater than 0, it's always going to be a spontaneous reaction. So let's do an example. So let's say you have a delta S system, delta S surroundings, and you have delta S universe. And you're given some values. Let's say this is 4 joules, and this is 4 joules. And the question's asking, is this spontaneous? Is this process spontaneous? So there's a big formula, a key formula to keep in mind when dealing with these problems that you may have seen before. And the formula is delta S universe is always equal to delta S system plus delta S surroundings. Okay. So let's plug these values into the formula. So you're just adding them up. So you have the system plus the surroundings. So if I add the system plus the surroundings, I get a total of 8 joules. And is this value greater than 0? Yes, it is. So this is going to be spontaneous. Okay, let's do another example that's a bit trickier in a sense. Okay. So let's say the delta S. Let me just do this. Okay. Let's say the delta S system. Let's say it's a bit different now. Let's say it's negative 2 joules. And then let's say the surroundings are, let's say 6 joules. So by this equation, you add them up in the same manner. So you have negative 2 joules plus 6 joules. That's going to equal a total of 4 joules for the universe. So even though this is negative, you might think, oh, negative, it must be non-spontaneous. But that's not the definition of spontaneity with entropy. The definition is if the delta S universe is greater than 0. So even though this is negative, if the total delta S universe is positive, like right here, it's going to be spontaneous. So this is something to keep in mind because it can get a bit tricky at times. So whatever the delta S universe is, that's what it is. So in this case, it is positive. It's a positive 4 joules. So that means it is spontaneous. So it's not just what the system is necessarily, but what the system and the surroundings are. Okay. Okay, and that's it for today. That's all I wanted to go over in terms of applications. So good luck with studying, everyone, and I'll see you later.